So here we are at the tail end of Chapter 4. This lesson is a little less heavy in the proof and a little more algebraic looking, solving for x, things like that. All of these are looking at types of isosceles triangles, and if you remember, an isosceles triangle has at least two pairs of, or two congruent sides. And the reason I include the at least is because equilateral triangles are types of isosceles triangles, just a very particular type. Some vocabulary words that you're going to need to know for these. For this isosceles triangle, the two sides that are in fact congruent are called the legs, and then the other side is called the base. And it does not matter where that base is. I know that you guys are probably really used to seeing isosceles triangles kind of drawn like this, where like the base would be the bottom then. You just really have to pay attention to like where the legs are, and then the base is just that other third side. There are two angles then that are opposite from those legs. The two angles that are opposite from each leg are called the base angles. And those base angles are the two that are adjacent to or right along the base. And then there's one other angle, that third angle, the one between the two legs, is called the vertex angle. So if you see those in problems, you'll know how to describe them. The next couple of theorems, I had always learned those as base angles theorems. Our book presents them as isosceles triangle theorem. I think base angle theorem will be the easier one to remember, and that's the one I usually say. So I just wrote that one out first. But again, if you're reading this in your book, you'll see that it says isosceles triangle theorem. It's just different authors say different things sometimes, and it just kind of depends on what you're looking at or what you're reading or what textbook you have. Both of these, I mean, it's the same theorem. What it says is it says that if you have two sides of a triangle congruent, so if two sides of a triangle are congruent, in other words, like if you have an isosceles triangle, then the angles that are opposite those, I'll write it out, opposite those sides are congruent also. In other words, the base angles are congruent. So this angle is opposite from this side, and this angle is opposite from that side. So those base angles would be congruent. I think that's why I think it's easier to remember that that's just called the base angles theorem. The converse of that theorem is also true. Remember, the converse is just when you take that hypothesis and conclusion and you flip-flop the order of those. So that would read, if two angles in a triangle are congruent, then the sides that are opposite those are congruent also. And looking at this picture, I have these two angles congruent, so I would look to the sides that are opposite from them. So I could say that DE is congruent to FE and go from there. Some examples of how we're going to use this. Some of these, they will just have a picture and there might be more than one triangle in there. So it'll be really important to name, especially the angles with 3 letters. Looking at this first question says they want us to name 2 unmarked congruent angles. So I need to look at the sides that are congruent within certain triangles to mark that. So if I'm looking at like this triangle here, do you see that I have 2 sides that are congruent? You need to look to the angles that are opposite those sides. So in this case, these would be your angles, and it might help to kind of draw those arrows on there. These would be the angles that are congruent. So you could say that angle FGJ, so FGJ is congruent to angle FJG. And that would be the base angles theorem, because you start with the sides and then you say the angles are congruent. For this next one, they want me to name two unmarked congruent segments. So for this triangle over here, I have these base angles that are congruent. So that would allow me to say that the sides opposite from them are congruent also. So GH is congruent to JH, and that would be the converse of that base angles theorem. You can also use this to come up with exact measurements of things if they give you different dimensions of a picture. For example, here I need to find the measure of angle M, and because these two angles are marked congruent and I know the one angle is 120, I can take 120 away from 180, and that would leave me 60 degrees for both of these, and then I can divide it by 2 so that each one of those would be 30. And because those are congruent, that would let me know that the sides that are opposite from them are congruent also. So the length of PN would be 11 centimeters. I threw these corollaries in here, just go over them with you really quick. An equilateral triangle is a type of isosceles triangle, and it says here if it's equilateral, if and only if it's equal angular, meaning if it's equilateral, it's equal angular, and also going backwards, if it's equal angular, then that makes it equilateral. And if you look at like these two sides being congruent, these angles would be congruent also, because they're the ones opposite those. Or if you look at like these two sides being congruent, the ones opposite from them would be congruent also. So when you have all of the sides congruent, all of the angles would be congruent also. And then if all of those angles are congruent and they all add up to be 180 degrees, when you divide that by 3, each one is going to equal 60. And that's just the case all the time. So you can either refigure that out if you forget, just knowing that you can divide 180 by 3, or if you just remember 60 degrees, that'll be a little quicker for you. So looking at this picture here, I am going to want to solve for x and y, and it shows me that this is an isosceles triangle, and since I know both of these sides are congruent, I would go ahead and just set those equal to each other and solve for y first. It's not like you have to solve for one variable before the other one. If you wanted to solve for x first, you could also do that. For this one here, I get 2y to equal 8, so y equals 4. Looking at this one then, it looks like these two angles are congruent, and they are in fact going to end up being that way, because I know that these two angles are the same because they both have 4x minus 8 and 4x minus 8. And I also know that these two angles are the same. So that would make all of these congruent. So even though it doesn't directly say this, I know that this is an equilateral triangle. And it will not be helpful to you to set 4x minus 8 equal to 4x minus 8, even though that is the case, because you're not going to be able to solve that and get one specific answer. However, because this is equilateral, all of the angles are going to be 60 degrees. So what you can do with that is you can set 4x minus 8 equal to 60, and then this is something then that you could solve. So when you solve this, you should get x to equal 17. Looking at this one here, again, it doesn't look like it's equilateral, but just because it doesn't look like it doesn't necessarily mean that it's not. However, I know that it's not because this is 80 degrees. So because this is 80 degrees, and if it were equilateral, they'd all have to be 60, I don't know that this is, well, I know that it's not equilateral. I know it's just isosceles. So I can do the same thing with these ones for the x. Because those are marked congruent, I can just set them equal to each other, and I can solve this. And going through, I get 2y to equal 4, or y equals 2. And then lastly, to solve for x, I need to figure out how many degrees this angle actually is. And that's the way I would do it. I'll show you a different way in just a second. But I would figure out that this angle is 50 degrees. And the way I did that was I knew that all three of these angles are going to add up to be 180. So when I do 180 minus 80, I get 100. And then I know that these two are the base angles, and they're going to have to be congruent. So they're going to be the same, so I can just divide that by 2. When I solve this, I get 6x to equal 42. Therefore, x equals 7. One other way you could set this one up is because you know that these two angles are congruent, you know that this one is 6x plus 8. You could add all of those together, all three of those angles within that triangle, and set it equal to 180. Again, you would get the same answer. I probably wouldn't set it up this way, but you would get x to equal 7 even if you did. I hope this helps, and I have a little video for you guys to watch here at the end. If you don't want to watch it, that's fine. You can turn it off now, but I thought it was kind of interesting. It's about interesting facts about our solar system. So enjoy the video, and if not, then you won't.
If you scaled the Earth down to the size of a cue ball, it would be smoother than the ball, Everest included. On Saturn, it may rain millions of pounds of diamonds every year. The atmosphere has such high heat and pressure that scientists think it can squeeze carbon into diamonds in midair. Jupiter is so big that it doesn't even orbit the sun. It revolves around a spot just above the sun's surface. The sun orbits that spot too, so it wobbles a little. Venus spins in the opposite direction than all the other planets in our solar system. Scientists think that the sun's gravitational pull flipped its axis 180 degrees. When the moon is at its furthest point in its elliptical orbit, all the planets in our solar system could fit in the space between our Earth and our moon. The Earth is currently moving 1,029 miles per hour, and our solar system is currently moving 490,000 miles per hour. It's a pretty good thing we have gravity to keep us on the planet. Our Milky Way galaxy is going to crash into the Andromeda galaxy in 4 billion years. The collision will likely fling our sun to another spot in the galaxy, but not destroy the Earth. The fastest thing in the universe is a pulsar called PSR. It's a collapsed star that spins 716 times per second. The molecular cloud Sagittarius B contains over 2 octillion gallons of alcohol. That's a lot of gallons. Scientists think that it would taste like raspberry rum.